Hello, welcome to my tutorial on 1D elastic collisions. So today I'm going to show you the quickest and easiest way to solve the 1D elastic collision problem. Okay, so what we have are two masses, M1 and M2. This is the positive x direction, this is the minus x direction, and they're both moving with some initial velocity. So v1i vector, v2i vector. They'll collide at some point and then move off with some final velocity, and the direction depends on the masses, but this is just for illustrative purposes, so it may go in that direction, it may not. It may go in this direction, it may not. We don't need to worry about that. When we solve the equation, it'll tell us. So this is V1 final, and this is V2 final. Okay, so we begin with the conservation of momentum. Conservation of momentum, which says that the final momentum is equal to the initial momentum. Final momentum of the two-particle system is equal to the initial momentum of the two-particle system. Now, the initial momentum of the two-particle system is equal to the sum of the initial momentum of each particle, which is equal to mv1i plus m2, sorry, that was m1 v2i vector, which we will then technically write as m1 v1 I in the I hat plus m2 v2 I in the I hat. And we'll do the same for the final momentum. Pf is equal to P1f plus P2f, which is equal to M1 V1f vector plus M2 V2f vector, which is equal to M1 V1f in the I hat plus M2 V2f in the I hat. Now putting them together, we have the final momentum equal to the initial momentum of the system, and that gives us, just writing this down, this is equal to this. So M1 V1f the I hat plus M2 V2f in the I hat is equal to M1 V1I V1I the I hat. Let me turn this light back on. Plus m2 v2i in the I hat. Now, since all of these are in the I hat, we can go ahead and factor out the I hat. And now everything in the I hat direction is equal to everything in the I hat direction, so it's just this is equal to that. Now subtracting m1 v1i from both sides, we have m1 v1f minus m1 v1i, and subtracting m2 v2f from both sides gives us m2 v2i minus m2 v2f. Factoring out an m1, on the left side we have v1f minus v1i. Factoring out an m2, we have v2i minus v2f. Now dividing both sides by m2 gives us m1 divided by m2, and then dividing both sides by v1f minus v1i gives us v2i minus v2f divided by v1f minus v1i. And here we have a dimensionless ratio proportionality. Which I will write down. This side, as I erase the second side to begin the conservation of kinetic energy derivation. So m1 over m2 is equal to v2i minus v2f divided by v1f minus v1i. And that's our first equation. Now looking at the conservation of kinetic energy, which says that the final kinetic energy of the system is equal to the initial kinetic energy of the system. Now, the final kinetic energy is equal to the sum of the final kinetic energies of each particle. So kinetic energy 1 final plus kinetic energy 2 final, and the initial kinetic energy of the system is equal to kinetic energy for the first particle, initial one, plus the initial kinetic energy of the second particle. Now, kinetic energy is just 1/2 mv squared. And technically, this v squared is the magnitude of the velocity vector squared. And to get the magnitude of the velocity vector squared, you just take v and dot it into v, which is an inner product. But since since we're dealing with just one dimension and everything's in the I hat, this will reduce down the same way it reduced down for the potential energy, or sorry, the momentum. So, writing down the final kinetic energy, which is equal to the sum of the individual final kinetic energies of each particle. We have m1/2 m1 v1f squared plus 1/2 m2 v2f squared. And the initial kinetic energy is equal to 1/2 m1 v1I squared plus 1/2 m2 v2I squared. Now setting these two equal to each other and applying the conservation of kinetic energy condition, we have 1/2 m1 v1f squared plus 1/2 m2 v2f squared is equal to 1/2 m1 v1I squared plus 1/2 m2 v2I squared. Now we can cancel out all of these 1/2s. They factor out and cancel. And I'm going to subtract m1 v1I squared from both sides. So I get m1 v1f squared minus m1 v1I squared is equal to, now I'm going to subtract m2 v2f squared from both sides. That gives us m2 v2I squared minus m2 v2f squared. And factoring out m1 gives us this. Factoring out m2 will give us that. And now dividing both sides by m2, we have m1 divided by m2, and dividing both sides by v1f squared minus v1I squared. We have v2I squared minus v2f squared divided by v1f squared minus v1I squared. And again, we have another dimensionless ratio proportionality. So what I'm going to do is I'm going to write it here. Rewrite it here. m1 over m2 is equal to v2I squared minus v2f squared divided by v1f squared minus v1I squared. And this is our second equation. Now both of these are dimensionless ratios of proportionality, and it's both m1 over m2 equal to something and m1 over m2 equal to something. And they look very similar except for the squares here. Setting them equal to each other. So since this is equal to m1 over m2 and this is equal to m1 over m2, this is going to be equal to that. So we have v2I minus v2f divided by v1f v1I is equal to v2I squared minus v2f squared divided by v1f squared minus v1I squared. Now we can rewrite this. Now v2I squared minus v2f squared will factor as v2I minus v2f times v2I plus v2f. You can easily check it by using FOIL. v2I times v2I is v2I squared, and then v2I times v2f minus v2f times v2I, which is the cross products there, they cancel out, and then minus v2f times plus v2f gives us a minus v2f squared, which is what we have here. And doing the same thing for the bottom, we have v1f minus v1I times v1f plus v1I. And this is equal to v2I minus v2f divided by v1f minus v1I. Now, we can cancel these like terms on this side and on this side. So that gives us 1 is equal to v2I plus v2f divided by v1f plus v1I. So now, multiplying both sides by the denominator, we have v1f plus v1I is equal to v2I plus v2f. Now solving for v2f, this gives us that v2f is equal to v1f plus v1I minus v2I. Okay, so what I'm going to do now is plug this into that equation and solve for v1f.
How you finish? Ah, you said, okay, good, done.
So rewriting that here, we have v2f is equal to v1f plus v1I minus v2I. That's equation number 3. Now all we have to do is substitute in equation number 3 into equation number 1 and then solve for v1f. So let's do that. m1 over m2 is equal to v2I minus v2f. v2f is v1f plus v1I. v2 v1f plus v1I minus V2I So that's V1F plus V1I minus V2I. And in the numerator and the denominator we have V1F minus V1I. Now, multiplying -1 through, we have V2I minus a minus V2I is 2 V2I minus V1F minus V1I. Divided by V1F minus V1I. I'm going to multiply both sides by the denominator. So we've got V1F minus V1I times M1. I'm just going to multiply through. So that's M1 V1F minus M1 V1I. And multiply both sides by M2. Gives us 2 M2 V2I minus M2 V1F minus M2 V1I. Now I want to solve for V1F because that's our only unknown. Everything else is known. We know the masses and we know the initial velocities. We're just looking for the final velocity, and now the only final velocity we have is M2 V1 or V1F on this side and M1 V1F on this side. So we add M2 V1F to both sides, and that gives us M1 V1F plus M2 V1F is equal to, now I'm going to add M1 V1I to both sides, and that gives us 2 M2 V2I minus M2 V1I plus M1 V1I. And now I'm going to factor out V1F. So this is M1 plus M2 times V1F is equal to, I'm going to write this in a form that will become obvious soon why I'm writing it that way. So we've got 2 M2 V2I And now these are both v1i's. And so we've got so let's factor out the v1i here, and we get plus m1 minus m2 times v1i. And then dividing both sides by m1 plus m2, we get v1f now is equal to m1 minus m2 times v1i divided by m1 plus m2 plus 2m2 divided by m1 plus m2 times v2i. And so we have solved for the final velocity of the first particle, and that's the quickest way to do it. Now we take the final velocity for the first particle and plug it back into this equation right here. And that will give us the final velocity for the second particle. And so that's basically it.